Hello. Let's create a pixelated image with OpenCV. We will need two libraries, CV2 and NumPy. Let's import CV2 and NumPy as NP. First, let's open our image. For that, let's create an image input variable and assign it to cv2.imRead. In brackets, write image destination and image name with extension, input, cat.jpg. In the project directory, I created an input folder to store the images. I also created the output folder for output images. So our first line just reads the image, we need the second one to open it. Let's write cv2.imShow and in brackets write window name and image input. Let's run the code. You saw how the window just stayed open for a moment and closed. To make it stay open, we need to add one more line, cv2 wait key and in brackets 0. 0 means the delay in milliseconds. Let's run the code now. Now the window stays open and we can see the cat. Next, let's check image properties. For that, we will use the shape function. It returns a tuple of the number of rows, columns, and channels. We have image height, 533 pixels, image width, 800 pixels, and 3 channels. We will need just the first two values. Let's assign them to image height and image width. Let's print them. Okay, next we need a new variable, pixel size. It will control how big we want our pixels to be. Let's start with 10. Next, we need to calculate the new width and new height. We divide image width by pixel size and image height by pixel size. We will use this operator to divide without the remainder because image size can't be with a fraction of the pixel. Let's add a print line to print the new width and new height. Before running the code, we can comment on some lines, like print image input shape and cv2 imShow. Let's run the code. We can see that we have a new image that is 10 times smaller, 80 pixels wide and 53 pixels tall. And if we change the division operator to the default one, we will have an image with float point dimensions. So let's bring back the correct division operator. What's left is to resize the image. For that, let's create a new variable image temp. Let's make it equal to cv2.resize. In brackets, we add source image, which is image input, a new size and a tuple, and interpolation method, interlinear. Next, we need to restore the image to its original size, but with bigger pixels. For that, we will use the same line. Just now we have image output, the source image is image temp, the new size is the original image size, and the interpolation method is internearest. This interpolation will create pixelization. We finish by adding cv2.imShow line. In brackets, we write window name, output and image source, image output. Let's uncomment this line to show the input image. Now we can run the code. Okay, we have two images, original and pixelated. Let's change pixel size and see how it changes. This is how an image looks with a pixel size equal to 100. And with pixel size equal to 1 we have the same original image. To save the output image, we write cv2.imWrite and in brackets, we write image destination with image name with extension and image itself. We showed two images on the screen but they were overlapping each other. There is a better way to show them side by side. For that, we will use the NumPy library. Let's create a new variable image horizontal and make it equal to np.hstack and in brackets, we add a tuple with images. NumPy will stack images horizontally creating one image. To show this new image we add an already known line, cv2.imShow and in brackets, we write window name and image input. Let's comment on unnecessary lines and run the code. We have created the pixelated image with OpenCV. Hope you liked this video. If you have any questions, leave them in the comments section. You will find the code in the video description. If you like this video, please leave a like and hit the subscribe button for more Python videos.